morning, students. Now welcome to the video number 5. I am going to discuss that one more case, that is what? Moment of inertia of a circular disc. In previous video I discussed regarding the moment of inertia of a circular ring and also moment of inertia of a what? Rectangular bar I discussed. Now this is the new case, that is what? Circular disc. Okay. Here again there are 2-3 cases are here. Case 1, about an axis perpendicular to its own plane and passing through its center of gravity. You all know about discus throw and all that, you know that. This is a flat plate, very thick kind of flat plate. Of course it is not so thick. Assume that it is a disc. It is a circular disc and all that. It is not ring. Yesterday I shown the same picture, it is for the ring. Where the ring that is inside it is what? Empty. That is what? The bangle or something. Now this is the what? Disc. In the disc, how that is? In this plane. Now the axis is like this. It is passing through its center of gravity. And perpendicular to its own plane. Perpendicular to its own plane. I think you got the point. It is like this. For this, now discussion begins now, that is. Just for the shortage of the place and all that, now I am reviewing. What is the case 1? Our axis, perpendicular to its own plane and passing through its what? Center of gravity. Okay. Here, first, mass of the disc equal to, this what? Mass of the disc. This is the mass of the disc equal to M. This is the completely, it is solid. It is completely solid. This is mass of the disc equal to what? M. Radius of the disc equal to radius of the disc equal to R. The next, mass per unit area. Mass per unit area, that is small m, equal to m divided by pi r square. Area of the disc is also what? Pi r square. Here, this is the radius. This is the what? Radius. From here, center, this is what? Radius is what? R. Assume that this disc is what? Consisting of smaller and smaller annular, that is what? The strips and all that. Now I am considering small strip, I am considering about this point. This is the small part of it. It is as good as, or this is the disc. Here I am considering the small part of it, I am considering this. When I consider only the small part of it, the mass is only comes within this region. This is the mass I have to consider. For this thickness is, I am writing, it is what? This is a thickness is a dx, I am writing, and the radius is what? It is x. This is the radius is what? X. I think you understand. That area of the imaginary ring equal to area of the shaded ring equal to shaded ring equal to 2 pi x into what? Dx. What is 2 pi? It is a circumference. Circumference multiplied by thickness, again meter into meter, it is what? Meter square. And also you know that the unit of area is also what? Meter square. Next. Here, mass per unit area, mass equal to how much? M divided by pi r. Here, 2 pi x is the what? Dx is the what? The shaded portion. I want, what is the mass of this shaded portion equal to? That is what? Mass of this shaded portion equal to, mass of the shaded portion equal to, what I can write? Mass per unit area, it is pi r square into what? 2 pi x into what? Dx. Any doubt? This is mass per liter. Yeah? This is the what? Area. This 2 multiply, it gives the mass of this portion here. Yesterday in the previous class also I told you that is. Next. But I am interested in finding the moment of inertia of the entire disk, that is. There. Now first I will find the moment of inertia of this moment of inertia of the shaded portion. Moment of inertia of the shaded portion equal. What is the formula for the moment of inertia? Mass into square of the distance. Already you know this. This mass, you know that. M divided by pi r square 2 pi x into what? Dx. Into what? X square. Here you see which are the factor get cancels here. This pi and this pi is what? Get cancelled. Get cancelled here or later also it cancels. This is equal to m divided by r square 2x into x square 2x cube into what? Dx. This is the moment of inertia of the what? Shaded portion. Anything left? M divided by r square 2x into x square into what? Dx. But I am interested in finding the moment of inertia of the entire disk. For that, I will reserve this portion. I have to integrate the above equation. This equation I want to integrate. Okay. To calculate the moment of inertia of the entire disk, integrate the equation. That is I equal to integration between the limits 0 to what? R. This is 2m divided by what? R square into what? X cube into what? Dx. Here the variable factor is x. M is constant, R is constant, so that I can write 2m divided by r square 0 to r x cube into what? Dx. Now integration of x cube equal to what? X to the power of 4. It is I equal to 2m divided by r square. It is x to the power of 4 divided by what? This is 0. This is what? R. Now I equal to 2m divided by r square into what? 1 by 4. It is r to the power of 4. Right? When it is r to the power of 4, then what happens? This 2 and this 2. R square, here r square. It cancels. Then what is left? I equal to m, I will write, divided by what? 2. Here r square, it cancels. It is m r square by what? 2. What is m r square by 2? It is the moment of inertia of a disk about an axis what? That is passing through its center of gravity and perpendicular to its what? Own plane. This is the moment of inertia of this. And I told in the previous class also, what is this other than m? Whatever the factor is there, this is called as k square equal to r square by 2. Therefore, k equal to r divided by 2. It is called as a radius of gyration. It is called as a radius of gyration. This is one case. Similarly, another two cases are there that I will discuss it now. Case 2. About its diameter. Earlier we found that passing through its what? Center of gravity. Now I will make a hole in it. Just assume that it is passing through this and then coming out, but I can't make the hole. It is like this. About its diameter. It is y dash. This one, it will become what? X dash. Here, see, one is y dash. This is y dash. If I consider like this is x of what? X dash. Students, you see, now I am going to apply, it is based on the symmetry and all that. And I am going to apply what? The perpendicular axis thing. Now, in this, I told you, no, that is what? Passing through its what? Center, and perpendicular to its what? Own plane. Can I turn it like this? It is like this. And this is what? X-axis. This is what? Y-axis. Imagine yourself, I can't hold all the 3 pens, I can't hold it. This is X, and this is what? Y. This is X-axis. This is what? Y-axis. This is the what? Z-axis. Yes. The Z-axis, nothing but moment of inertia of a circular disc about an axis passing through its what? Center of gravity and all that. Here, now I can write, it is I of center of gravity equal to Ix plus of what? I. It is nothing but Iz. It is nothing but Iz. Because we know that perpendicular theorem, it is one is the x-axis and what? Y. Both x and y are in what? In its own plane. Now I am considering another axis I am taking here, z-axis. It is perpendicular to its what? X and what? Y plane. It is just not like this. This is z-axis. This is x-axis. And this is what? Y-axis. Now I am applying, that is what? ICZ, that is equal to Ix plus I. But of course, here, this because of symmetry, either you can measure it like this or you can measure it like this here. The mass distribution is same, the radius is also same, so that can I write Ix equal to what? Ic. Here, this IR m square by 2 equal to what? 2Ix. Therefore, Ix equal to m r square divided by what? 4. This is the what? Moment of inertia of a circular disc about an axis passing through what? Y, y dash, or x, x dash. Or else we can write I, y equal to m r square divided by what? 4. So, I think we can able to understand this one. This is case 2. And one more case is that, now, I will discuss it now. Students, case 3. About a tangent to the disc. About a tangent to the disc in its own plane. Please try to understand. Is it in its own plane or perpendicular to its plane? What is the difference? This is your plane of the disc. If I draw the tangent like this, now it is what? Tangent to its own plane. And I am considering another one. I am considering this is what just now I discussed. This is the axis, this is a line passing along its what? Diameter. Now are there not two parallel here? This is the situation in its own plane. You may ask the question, if it is perpendicular to its plane, it's like this. This is tangent is like this. This is a tangent. This is a tangent. But in order to apply the parallax theorem, now this is what? Iz. This is what? Iz. This is what? This is the axis like this. For this, it is not in its own plane, it is perpendicular to its own plane. Perpendicular to its own plane. But now I am discussing like this situation. I am discussing this. It is like this. I am discussing. Tangent is like this. And another axis I am taking here. It is what? Along its what? Diameter. Now, say this is the axis I am taking. X, x dash. And another axis I am taking here. It is along the diameter. It is y, y dash. I think you can understand this. And distance between them is what? R. Now, using parallel axis theorem. Parallel axis theorem. It is plural, it is parallel axis theorem. Moment of inertia, that is what? It is passing through what? X dash equal to, now you have to, it is I of what? Y dash plus of what? M into what? R square. Now already you know this, it is what is this value here? It is M here. This is equal to M into what? R square by 4 plus of what? M R square equal to 5 by 4 into what? M R square. This is the, it is x dash. What is x dash here? Tangent. This is the what? Tangent. Here. What is the, can I write like this for me? M into what? 5 by 4 into what? R square I am writing. Here, here, whatever other than M is there now, this part is nothing but what? Radius of k square equal to 5 by 4 R square. Then k equal to 5, that is a root of 5 by 4 into what? R square. Or else I can write root 5 into what? R divided by what? 2. This is case 3. I think you understood this. In that is, how many cases are there? 3 cases. One is what? Passing through its what? Center of current. And another one is what? Along its what? Diameter. And another one is what? Tangent. And of course, case 4 is there, but it is not in your syllabus and all that. That is, this also tangent. But this tangent is how it is? Perpendicular to its own plane. This is how, in its own plane, difference, in its own plane. Or parallel to its own plane. This is how it is? Tangent. It is like this. Perpendicular to its own plane and all. All the 3 cases I discussed. Then lastly, the one more case is left here, that is what? Solid sphere. Moment of inertia by solid sphere. Students, definitely will get in the moment of inertia chapter one question on this. Here the possibilities are either the rectangular part or annular ring or what? Disc or else what? Solid sphere. This is one possibility. And another one is what? That is the statement regarding the what? Parallel axis and perpendicular axis. One more thing is that is law of conservation of angular momentum. Or sometimes छोटा मोटा definition they may ask you, define radius of gyration. What is radius of gyration? That is the axis where it is passing. It is passing exactly where the center of the mass is what? Located. Where entire mass of the body is what? Located. That distance we call it as a what? K. K is also in meter, students, because R is in meter. This K is also in what? Meter. It is the unit of length. This is the unit of what? Length and all that.